You can see the dovetail jig, and here I am clamping the one of the tail boards that I've already prepared with the two outside half pins. I clamp it so that it's oriented correctly, squared to the caul, and clamp it down using the two knobs. This dovetail jig, the plans exist at the website woodskills.com. It's included with with a couple of classes or courses. So it's important to align it correctly using a metal engineer square. It was just shown. Then I take a sharp chisel of the correct width and strike it with a mallet to clean out that center portion, which separates the two tails on the board. So I alternate between wider and thinner chisels, and using a mallet to lightly strike the chisels to clean that center portion out. So what the jig does is not only align, but it prevents you from going too far back on the baseline. So I've been using this particular style of dovetail jig for years, for a number of years now, successfully. And I use approximately 3 chisel sizes to perform this, depending on the width of the pin and the width of the tails I've selected. This is a small drawer for a small cabinet, so I've decided to only have two tails and have narrow pins. So the process involves striking from the top and cleaning out, because we've already sawn the sides of that center portion. So I continue with this until I've reached very close to the bottom, and you'll see that I then flip the board around, the tail board. You can either go completely through, or I prefer to flip the board over and make a clean cut from the opposite side, and you'll see that shortly. So it's important to have very sharp chisels to perform this, and it slices the wood instead of compressing it or tearing it. It's cool how the divots just pop out, because they've already been sawn and it's just a matter of chiseling them out. So you can actually see the two tails now, and I'm using that same circular technique I mentioned to clean out that center portion. So I usually work from the outside of the board in, because the inside of the half blind tails are hidden within the pin sockets. So I'm always work from the outside to the inside, and the board's completely marked, so there's no error, no possibility for error. But this is just the beginning of the fitting, and this is just an approximate. I mean, it's very unlikely that this tail board will fit the pins at the very first trial. What I'm doing now is I'm actually marking the opposite side of that pin board or drawer front with the tails. So once the tails are cut and cleaned, or at least mostly cleaned out, I clamp the pin board in vertically, as you can see, using the other caul and or cleat and knobs. Ensure that it is perfectly perpendicular. Bring it down flush with the surface. Here I am ensuring that it is perfectly perpendicular using a metal engineer square. I tend to use metal engineer squares. They're they're consistent and accurate. So once I've done this, I reclamp the tail board to align with that pin board, and the allowing for that offset in the front, because it is a half blind dovetail. So the it's not a through dovetail, so it doesn't protrude through the pin board. Using a smaller engineer square again to align the two boards. There's a considerable trial and error here, because it's so critical to have this the alignment done correctly before even beginning to clean out the pin sockets and mark them off. So I clamp everything down securely and then use a metal marking knife of your choice. I've chosen this one to mark off the outline of the tails and transfer that to the pin board. So I begin by marking the outside of the tails. I do this very judiciously. I try not to overshoot the outline of the tails. So I use a knife to create a mark that I can highlight or enhance with a pencil afterwards, a fine point pencil. Use the same marking knife to outline the top or the front of the tails. Best to take your time with this so you don't overshoot and don't have double lines or anything, and have the correct line marked off. So once I've done this, I unclamp that pin board and I have the outline for the tails. And as I mentioned, I highlight this using that same mechanical fine point pencil. This helps. This step helps a lot in the sawing. The next step of sawing them out. I can't emphasize how important marking is, because you have only really one chance to do this correctly, and is very dependent on precision marking. Use that other technique of marking off where I need to remove the material from the pin sockets. Cuts are correct. And then reclamp the board horizontally. And what this step involves is chopping out the pin sockets. So I ensure that the board is the baseline is perpendicular to the cleat or the caul, and before clamping it down, using a metal engineer square. A little trial and error here to ensure that the board is oriented correctly and aligned, because the cleat or the caul serves as a reference for the back of the chisel when I'm chopping out the pin sockets. You'll see shortly. So I begin the process of chopping strike the top. So this creates a cut from a clean cut from the top along the baseline for either of the pin sockets, and then use a different width chisel to pop out that slice of wood. Because the sides of the pins are sawn, the wood just pops out. So it's important to have sharp chisels to ensure that the slices or slivers are cleanly removed, and not tear out the wood that shouldn't be removed. So there's considerable back and forth with this, of striking vertically and then cleaning out horizontally. Once you've done this a few times, it's not as intimidating. There's less opportunity for error too. You'll begin to understand how far you need to go, and how much an impact, or how much to tap the chisel with the mallet. So although the process appears very tedious, it's critical to get this right, because then the fit of the tails when the sockets won't be correct. So it's better to spend the time and be patient and do this correctly. Most of my drawers are small, because I make smaller cabinets and I only need small drawers. So I don't mind spending the more time at this and doing it correctly the first time, because all the parts, the components, the drawer front, the drawer sides are pre-cut to the correct width, and so it's, although I do create spares in the event of an error, of a mistake. The Dovetail Jig is very good at keeping the border lines, the line, so when I'm chiseling through, I don't overshoot and cut where I shouldn't be cutting. So it's important to have sharp chisels when you're performing this task. I usually hone my chisels before I do dovetail works to ensure that they're sharp, and this creates more of a slicing action as opposed to a compressing or tearing action with the chisel. So I continue with this process until I've reached very close to the bottom. Now let's not forget that the saw cut was at a 45-degree angle, so there is a corner that's not sawn, and that's what we're going to work at in the very next step in the next video segment on cleaning that corner out. But until we get to that point, it's best to try to remove as much as possible using this process of striking vertically and then striking horizontally. I've only ever made hand-cut chisels. I've never used any advanced router jigs or anything like that. I much prefer this because, as I mentioned, my drawers are typically smaller. I don't do production work, so I'd have no problem at all spending the correct amount of time doing this. It also allows me to create different sized tails and pins, so it gives the appearance of handmade dovetails as opposed to machine-made dovetails. If I can make pins, I can, as in this particular example, the pins are very, very narrow, which you cannot perform with using router-based dovetail jigs. So I keep doing this, and as we get closer to the face of the drawer, the bottom of the pin board, the tap